So in today's video lecture, we will show you the demonstration of double barrier laminar broadgate deposition technique. And so in this video, you will understand about the working principle of the LB deposition technique, and you will also understand the operation of the instrument. Okay, so a couple of my students will be showing you the demonstration part. Okay, using the LB deposition technique that we have in our facility, which we have established in our lab called Colloid and Interfacial Engineering Lab. Okay, so let's begin.
My name is Richa Ranjan and I am currently pursuing PhD in Chemical Engineering Department under the supervision of Dr. Manigandan Sabapati sir. Today I'll demonstrate about laminar blockade system. A LB system can be defined as one or more monolayers of material deposited from a liquid surface by vertical dipping of solid substrate from gas phase into liquid phase. Now let's see the system. Welcome to the demonstration of LB Apex instrument. LB system are very useful instrument for fabricating and characterizing single or multi-layered thin film. LB trough are used to measure surface pressure during the formation of monolayer by compressing molecules on the surface of deionized water. The single and multi-layer thin LB film can be used for different areas of science and technology ranging from optics to rheology, nanotech and biotech. Film with a very accurate thickness can be formed. The monolayer are usually composed of polar molecules with a hydrophilic head and a hydrophobic tail, for example, fatty acid. The LV technique is used for the formation of ultra-thin ordered multilayer film with well-defined molecular orientation and an ordered layer structure. The thickness of LV film is controlled by the number of organic layer deposited. In addition, other properties such as density, homogeneity of the monolayer are preserved when transferring the laminar film. Thus, LB technique can control the degree of surface coverage deposited on the solid surface depending upon the pressure applied. Initially, it was discovered by Langmuir in 1918. 16 years later, Catherine Blodgett discovered the process could be repeated. Thus, it leads to multilayer. What makes LV appealing? Appealing feature of LV film is intrinsic control of the internal layer structure down to the molecular level and the precision control over the resulting film thickness. Sophisticated LV trough allows to process several material with different functionalities and offer the possibility to tune layered structure according to the demand of desired molecularity engineered organic thin film devices. First, switch on the power button. Then this red light on the power button, long press it. Then this whole unit is control unit. As you can see here, this is light and fan. Press on the light button. Fan, we don't need fan. Now switch on the balance power, which is in the top of the equipment. Open the software by double clicking on it. Press yes. The initial window will open, which will show about the information about barrier and dipper. Initially, we don't have dipper with this instrument, so we will fix the barrier position of the instrument by cross-checking the manual scale attached with the instrument. Minimum limit of the this scale is 25 millimeter and the maximum limit is 250 millimeters, and then press OK. When we press OK, new dialog box will open. As you can see here, the first one is data, then initialize, motor, isotherm, deposition, time versus pressure, time versus area, and help. So when you click on the data, you can see here it shows load data. We'll click on the load data, which will show the previous data file. We can then go through the saved file. Which will show what we have done previously. We can open that file. Then we go to initialize. We use initialize for limit setting. Then we go to motor, click on motor, and then press barrier expand and compress option. Now you see here we have new window open. Now we'll check the upper and lower limit, left and right limit of this instrument. The minimum speed of this instrument is 1 millimeter per minute, and the maximum speed is 75 millimeter per minute. Now the set speed is 25 millimeter per minute. Now we'll compress this. And when you start, click on compress tab, and the barrier will start compressing at the speed of 25 millimeter per minute, as it is the set speed. If you want to stop the process, click halt, and you can see the change in the position. This now you see this. Now you see this SP, that means surface pressure on the trough. Now we'll go to an interposition 200. Then press go to, we can see the barrier compressing very slowly, but it is compressing at the speed of 25 millimeter per minute. Now this is a zeroing SP, which will initialize the zero surface pressure. Then press expand if you want to expand. Press isotherm deposition, where you see these two load parameters from previous file, set new parameters. Press set new parameters. Press OK. New window will open. As you can see here, the surface is named water. Now, otherwise, you can always click on default, where you see all the other values have been filled, load default. Then you will see the other values have been filled. Now we'll just change the temperature to 20 degrees Celsius. And then we can change the concentration to milligram per ml. And the concentration is 0.5. 0.5. Now we'll go to control pressure, and if the sample is unknown, please click manual. If you click manual, we see that the control pressure is 80. Then now we'll set the compression and expansion speed to 5 millimeter per minute. Both of them will be same. Then click yes. Then want to correct input, press no, yes. Then all inputs are correct, yes. Click yes. Want to save it? Yes. Now, as you can see here, this is barrier moving in 2x speed. It is showing compression and after sometimes expansion. So initially, you need to know what can you do with this LV instrument. First, this creates functional coating with nanoparticle, altering their wettability, reflectability, compatibility, conductivity, and binding properties. It can also form model cell membrane at air buffers interface, and you can also study the effect of toxin or pharmaceutical on cell membrane. It also form thin polymer film to study polymer cross-linking, stability, and degradation. With this, you can study the interaction, adsorption, desorption, interfacial stability, and the structure of amphiphilic molecules. You can also go through interfacial rheological studies to determine film stability and phase transition or reaction. This LV instrument has unique advantages leading to extensive uses of them worldwide, which includes precise control of molecular packing density, precise control of coating thickness, homogeneous deposition over a large area, enable multi-layer structure with varying layer composition, high flexibility in using different kind of particle substrate, and coating quality can be pre-monitored prior to deposition. It can also widen your view. Now, as you can see here, LB has inverted microscopy attached to it. Now, below down here, these are the chord adjustment for the objective. Fine is for micrometer and the other one is for millimeter. You can focus through here. It rotates in clockwise and anti-clockwise direction. Now, here is the eyepiece. Both of this are adjusted with the scale according to your eye and the focus. The 0 is for default. The interpupillary distance is 50 to 75, and this is an simulator for the light beam. It indicates that the particle will be visible through your screen. We can switch it out and see through the eyepiece. Now, I'll show you filter attachment. The blank position is for incident light. The blue is for excitation in blue and emission in the blank. The green is for excitation in green and the emission is in red. Now we are going to back for the incident light. Now here I'll show you shutters, which is positioned at the back. The first position is for anti-filters. The second one is for fluorescence, and the third one is for blocker of fluorescence. Then we can work on normal microscopy. Here, this is the power supply unit for fluorescence. We have switched it on. As you can see here, it shows time and current. Lifetime the fluorescence has and the current. For fluorescence and mercury light, the lamp has for halogen light. These are this is the condenser aperture. This position is closed and this position is for open. The downward position is for open and the top position is for closed. For setting up of numerical aperture, you can adjust it through here. These are the phase ring for 4x, 10x, 20x, 40x for unstained sample. 4x, 10x, 20x, 40x. This is up and down position, open and close. We can adjust the height of the eyepiece up and down. See, it is going down, then now it is going up. We can move and adjust it according to our sample. So, for cleaning purposes, we need ionized water, that is milicu, and solvent like acetone or chloroform. We use Kim wipes for all the cleaning purposes. So, initially, we'll start the cleaning by cleaning the trough by using Kim wipes. We will take fresh Kim wipes and then wipe off the uh, trough with light hand. No scrubbing is required. Initially, this barrier and trough are made of Teflon material. We just gently need to wipe down the surfaces. Then we can wipe down the surface with a solvent, that is chloroform or acetone. On the Ken wipe, then we can clean very thoroughly. Cleaning on the edges, middle part is also required. So there is no molecules entrapped on the trough. Now we'll clean the barrier uh, with solvent on Chem wipe and wipe down the surface gently, very gently. We clean all the edges of these barrier and then we'll place barrier directly onto the clean trough. Then this is the other barrier. We need to wipe down this with the solvent. Now we need to ensure that the barrier are in the correct position. Correct position to the scale. Now we'll put the scale into perspective with the two barriers and attach to it, so that when the barrier moves, the scale also moves with it. Now we'll fill the trough with milky water. We'll start pouring the water on the turf surface, as you can see here. Very slowly, so that the water does not fall from the edge. Very slowly, but we'll fill all the turf surface area with water, so that the water surface level are with the edge of the turf. So now this is ready. This LB equipment is ready for the sample. So here we have prepared the sample solution, and what we are doing is we are dropping the sample drop wise on the turf at random places, in the whole of the turf at random places, so that the surface pressure reaches to 1. Now we'll again set the parameters according to our sample. So we'll check that the barrier position are in accordance with the scale. Now we'll press OK. And now we will set the parameters accordingly in accordance with our sample solution. Here you can see that we have changed the pH to 7 and the room temperature to 20 degrees Celsius. Now we are changing the concentration of the sample to 0.5 milligram per ml. And now we'll set the molecular weight, that is 284.48 gram per mole. The volume spread is around 200 microliter, and then we set the control pressure to manual and the compression and expansion speed to 5 millimeter per minute. Both of them will be same. and then we'll press yes. Then yes, again yes, and do you want to save it? Yes. Then we'll set up file name and then save it. Then a new deposit window will open automatically. As you can see here, the current position is 209.2 millimeter. Now we'll press isotherm. Then the compression will start. And then during this time, please do not touch the system. So no disturbance is required during the when the compression starts. As you can see here, the system has started working, and you can see here that the compression has started. After some time, you can see that the graph has started forming between surface pressure and surface area. Now we have switched on the microscopy and fluorescence. And as you can see here as you can see, then we go to data, load data, then this file open, select file, then open, and we'll open today's saved file data. Then here you can see all the parameters like surface area versus pressure isotherm, and you can see this graph. And here at the you can see the raw data of the plot can be seen on the bottom right corner. Now we can switch on to surface area versus pressure isotherm, and you can see this graph growing on the top, and again the raw data of the plot can be seen on the bottom right of the corner. This is the graph between surface area versus pressure. Now we'll convert this file to CSV. Like in you can open this file into Excel. Click OK, then close. Then again, we are just doing this to obtain the raw data, so we can make a Excel file to it, and then see we open. Then say the CSV file we open, and then just copy all of this to Notepad. We can also copy this to Excel sheet, and then make the graph according to our need. Thank you.